All right, so let me share my screen so we can get started here. I have just started us off with a basic project. It's just a C# console app in Visual Studio 2022. And I have the framework set to .NET 8. This framework is currently supported in Windows, but we have had success with testing in Linux environments, so it is something that we are hopeful and looking to add support for in the future. So in our project, we want to start here with our dependencies. So the OPC Wizard dependencies have already been added in this case, but let's start by looking at those. There's two main ways I would recommend getting started. If you install OPC Wizard through the setup program, which you can download from our website called OPC Studio, you can run sample projects that are included with it, which already have everything pre-configured, as well as pre-compiled projects that you have available as demos. The OPC Studio installer also includes OPC Data Client, which is the OPC client toolkit, and that allows you to create custom OPC UA and OPC DA clients, as well as the Excel connector, which is another feature that you can download and play around with. The installer has quite a few other features that are pretty cool, so we'll take a look at some of those later. Alternatively, if you prefer to get your hands dirty and just get started in a project like this, you don't even necessarily need to download the installer to do so. The OPC Wizard assemblies are provided via NuGet packages, so you can add these packages in your Visual Studio project by right-clicking on your project and then going to Manage NuGet Packages. So in that interface, you should be able to install the OPC Wizard assemblies, the necessary package for you to start developing your server, just by referencing opclabs.opc wizard. So you can see here, I already have it installed, but you can also manage the version of the package from this interface. So if you're maintaining an existing server, you can continuously update it as new releases are put out. So with that said, we should be good to go here since we already have everything installed, and we can start by building our server out. There's a couple things that we'll need to look into to start, but it is quite quick and simple. So the great thing about this toolkit is it handles a lot of the underlying complexity of an OPC UA server for you, as Zach mentioned. So it only takes a few lines of code to set up something basic. We mainly need to create the server object, create the items to populate the server, and then start up the server. So those are our three main steps that we'll be looking into here. So let's start by instantiating our server object, and I'll just call it server. So we'll add some code here, and you can see I have my usings up at the top. These are just the references that I'll be using in this project, but we'll just start by creating that server object, as I said. The server component has a lot of basic defaults built in, so you can just jump in and get started with testing with some underlying security, like minimal security, so that you can build on top of that and configure it as you need without having to start with everything already set up and not necessarily know what minimal components are needed from the client perspective. So you should just be able to access this server on the default endpoint, which is using the port 48040. So I'm actually going to make a note in my console application for ease of reference. And this will just be our default endpoint, which is on the local machine. So 48040. Okay, cool. So the next thing that we'll want to do, as we said, instantiate our server object. We want to create the items to populate the server. So we will start with our first tag that is going to be inside of our server, which is just going to be a tag that we'll read. So I'm going to just be giving it some random values for us to simply access from the start. So I will just create my random variable here to be accessed later. And then now we want to create our tag in the server. So this will be using the object UA data variable, which we will attach to our server object. And then we will assign it some kind of operation that we want to occur whenever a client reads that tag. In this case, we want to update the value so that it reads a new value every time. So we'll do that using the server add function. And then we're going to add the UA data variable. And as you can see, as I'm typing out these commands that I'm building my server with, there's a lot of good documentation that's available even just through the IntelliSense, which can be used for just ensuring that you're on the right track. It has a lot of great notes that can make it a lot easier to ensure that you're building it out in a way that makes sense or that is expected within the design of the toolkit. So here I've got my data variable and I'll just call it data variable read. This is actually going to be so that's effectively all the definition of the tag needs, but we want to give it that random value. So we are going to assign the read function to a Lambda expression that tells the server, which is what we're pointing this tag into, that it should update the value of that tag anytime the read operation is called. So we'll use that read value function on the UA data variable object. And then from here, I'm just going to make my Lambda expression that updates random. Okay, so this is all we really need to define the tag. Now we just need to start the server, which we can do simply with the server start function. I'm going to want to keep the server running, so I'm putting in a read line, and then we'll be able to exit the console application when we hit enter. So I will make another note here for anybody who's accessing this console interface. And then all we need is the reline. And then we can stop our server. So this is our bare bones project with one tag where we should be able to access at this endpoint and read values from this tag. So I will go ahead and start this project and we should be able to see that. The installer of OPC Wizard, OPC Studio, includes the examples for OPC Wizard as well as the OPC Data Client Toolkit, which I will actually be using as my test client against the server. So you should be able to see the behavior from the client side and verify that the tag is up and available. So we can start the server now and confirm that this is running just through the console interface and then access it with our client. Forgive any slowness. The screen share has been a little bit hefty on my machine, so there we go. So we're up and running, and now I should be able to access through my client, which I have here. So I've already put in our server endpoint, and then our node ID for our data variable read. The namespace of 3 is the default. So this should be all we need to get good values. So if I hit read, we can see it's updating just fine. Good values are coming in. And if I hit subscribe, you should get those continuous updates on the subscription interval. So here we can see the values updating whenever we have that publish occurring, but I can also increase this to something like 500 milliseconds and it'll be updating just a little bit slower. So this is it for reading an item. That's all you really need. That's what makes the toolkit really nice and accessible for somebody who's just trying to get started. So I would definitely recommend if you do want to just jump in and start playing around with it, you should absolutely try something this simple and simply use what's within the toolkit itself. You can get started with your testing. But this is obviously only the read and subscribe operations. We also want to perform writes potentially from the client. So let's go ahead and do that. And we should be able to get that set up pretty equally simply. So we have our read variable. I'm going to create a second variable for our write. We can assign an entire function to the operations read or write. You can also just assign an action, like a singular action to it through a lambda expression, which is what we'll do for our write operation. You can also switch these so that it's a read value action. You don't have to set up an entire potential function with many commands if you choose not to. But with a function, you can do things like also assign a quality or a specific timestamp if you choose. So let's create our write operation. We will do a similar setup here where we're adding it to the server as a new data variable. And I will call this data variable write instead of read. And where we're performing our read value function, I will perform a write value action. So and here we want to, because it's a write, we want to make sure we're defining the data type for the specific write operation. And now we should be able to define our lambda expression that is being passed when this write operation is performed. So we're wanting to use that value as a parameter, and then whenever the write is performed, I'm going to print to the console just a notification of the value that was written. So that's what we will set up here. I'll do it like this. Okay. So this should be, again, all we really need to define a right to an item here. So let's again see this in action. So let me start up our server. There we go. All right, so we've hit our server start because we saw that press enter to quit message come up. So now we should be able to access that server endpoint. And this time, instead of just simply inputting this item, we can actually browse the server and be able to pick out the specific tag that we just created. Any day now if you like to. There we go. Okay. So there's our write variable. And I will pull that tag in. And as you can see, it's got this this namespace URI, which it's prepended to the node ID, and the rest looks similar to what we had specified before. This, you can consider this implicit as like the base. The read item that we created is also inside of this NSU, namespace URI. So either way, it should work for you. But we should be able to see if I read that item, it has a good value of 0. I should be able to subscribe, and it should continuously get any updates. So if I write something to it, we should be able to first confirm that the value updates in the client side, and then in the console we should get that event occurring where the right function or the right action that we defined will occur and print out our value. So we should get the value written to 5. We can see the value is 5 now, and I should be able to continuously change this and get updates. Nice. So that's basically the main components that you'd really need to build out your server.